Hello YouTube creators and subscribers, I just wanted to thank you all for tuning into my video. Today we're going to be going through a topic of Earth's history. Now this is the next in line after the Archean Eon. It's the second period of time on Earth, and it features the creation of water and accumulation of some new rock formations. So we're going to go through this eon. The eon is named Archean Eon. The Archean Eon is one of 4 geological eons of Earth's history, occurring 4,000 to 2,500 million years ago. During this time, the Earth's crust had cooled enough to allow the formation of continents and the start of new life. Archean derives from the ancient Greek word ar-KEE-än, which means beginning or origin. The Earth's heat flow was nearly 3 times as hot as today. The extra heat was created by a mix of remnant heat from planetary accretion, from the formation of the metallic ore and core, and from the decay of radioactive elements. So as you can see in these photographs here, these are the rocks that were formed in that time period, and it's leaving some kind of trace of water. Now, in the in-depth research, these photographs will show that scientifically water was flowing when these rocks were being created, hence it leaves these interesting patterns. So the Archean Rocks and their locations. The location of these formations of rock masses were in Greenland, Siberia, Canada Shield, Montana, Wyoming, Baltic Shield, Rhodope Massif, Scotland, India, Brazil, Western Australia, and Southern Africa. Archean Rocks. Granitic rocks are common throughout the remnants of the surviving Archean crust, and we can see the different various rock formations and their types here in this slide. And the examples are granite, dorite, layered intrusions, anorthosites, monzonites, and sanutoids. And those are the different rocks we got pictured here. The rocks are often metamorphized through deep water sediments. Examples: gray whackers, mudstone, volcanic sediments, banded iron formations, carbonate rocks are rare in this period. Greenstone belts are typically Archean formations, and the Archean felsic volcanic rocks. As we see another depiction of that same rock here. So the metamorphosis of the ingenious rocks were derived from the volcanic island arcs, while the metamorphized sediments represent deep sea sediments eroded from the neighboring island arcs and deposited in the Forearc Basin. Greenstone belts, being both types of rock, represent structures between the proto-continents. Komatiites Rocks. Volcanic activity was much higher compared to today's activity. This activity is validated by the scientific study of the Komatiites. These are rocks. This rock is pictured here, is that type of rock. There was a lot of volcanic eruptions as well. Now the Komatiites are conventionally considered to be derived from high temperatures, melts that have eruptions, temperatures of about 1600 EC, and are produced by high degrees of anhydrous melting of mantle plumes. These rocks are very common in this eon. This rock has economic interest as they are associated with the significant magmatic nickel sulfide ore deposits in Australia and Canada. Komatiites are an integral part of the subaqueous volcanic successions of the Precambrian greenstone belts. Environments and facts. The continents started to form in this eon. Lack of extensive geological evidence to provide full details, but there still is evidence that the continents started forming at that time. And you can imagine that the lava from all the volcanoes in the previous era was created huge land masses that were able to coalesce into physical continents that are stable. So one theory states that the rocks from India, Western Australia, and Southern Africa formed a continent called as of 3100 MA. Another theory suggests that rocks from Western Australia and Southern Africa were assembled in a continent called Valbara as far back as 3600 MA. And the two different comparable continents are represented in these photographs. Now, the one on the left is the continent and the one on the right is the continent Valbara. Two theories that are presented in such case when analyzing the creation of the Earth. Now, the oceans were more acidic due to dissolved carbon dioxide. So although the first continents formed during this eon, it only makes up about 7% of the present cratons. Evidence suggests that only 5% or to 40% of the present area of the continents formed in this eon. So very small amount of current day landmass was formed during this time. At the end of this eon, plate tectonic activity may have been like that of modern day Earth. Liquid water and deep oceanic basins existed in this area. The suggestion of assembly and destruction of one or perhaps several supercontinents. This is theorized that the atmosphere nearly lacked free oxygen. Astronomers think that the sun had about 70 to 75% of the present luminosity and potential presence of greater greenhouse gases. Now, the convective motion of the Earth's interior would have brought all proportions of the mantle close to the surface in a relatively short period of time, geologically speaking. Early life. Any reduction carbon species in the atmosphere would have been rapidly oxidized by photochemical reactions involving water vapor and its photoanalysis products. The decrease with time in the carbon content of ocean and atmosphere has been a consequence of the growth of continents and the large carbon reservoir that they support. How life arose on Earth is still not completely understood, but there is evidence that life came into existence either near the end or early in the Archean Eon. Early evidence is found in graphite of biogenic origin inside 3.7 billion year old rocks in western Greenland. This is one of the rocks that is featured in the studies in western Greenland. Water partly comes from the Earth's mantle, which contain lots of hydrogenated and hydrated minerals. Water would have escaped from the mantle through volcanic eruptions and got into the atmosphere. Another source of water is icy asteroids and comets that struck the planet. Amino acids, the building block of proteins, and nucleobases, which is an integral to DNA, came from comets, asteroids, and meteorites. So life itself was probably sent to Earth from these different comet, asteroid, and meteorite impacts. Organic compounds would have accumulated in the primordial oceans and could have been concentrated by freezing or evaporation of the water. Further reactions could have led to increasingly complex molecules, including small polymers. Earliest fossils consisted of stromatolites, which are microbial mats formed in shallow water by cyanobacteria. These are the mats right here. Cyanobacteria is this green looking stuff, and this is the stromatolites. Very interesting creature, or very singular celled life form. Not very complex, and doesn't actually have any kind of physical form or body, just very indifferent shape. Earliest fossils found in Western Australia. Cyanobacteria was instrumental in creating free oxygen in the atmosphere. Further evidence for early life is found in 3.47 billion-year-old barite in the Warwana group of Western Australia. Fossilized microbes from terrestrial microbial mats show that life was already established on land 3.22 billion years ago. Alright, so we're going to go ahead and go through this part. This is going to explain single-cell organisms.
Prokaryote.
So a prokaryote, over time, started to form in this eon, comprising the Archean and the bacteria. They tend to be smaller than 10 micrometers, have no nucleus or internal membrane-bound structures. Their DNA is a single loop, setting freely inside the cell. Generally, Archean and bacteria are unicellular, reproduced by simply asexual splitting or fusion. They obtain energy by a wide variety of means, meaning that they could breathe all kinds of elements, from hydrogen sulfide to iron. So as we could see, the kind of life form that was existing in this eon was very simplistic, and it had a singular cell formation. So that's the bacterial outside, this cytoplasm, ribosome, mesosome, and then the DNA, some other things.
Eukaryote.
So eukaryotes are said to exist at this time, but it took a while for them to develop, and most likely, according to scientific studies, eukaryotes developed in the next eon, the next phase of Earth's history. But we're going to go ahead and speak of these cells anyways. Cells tend to be larger than 10 to 100 micrometers, so a little bit larger than the other form of life, and they possess organelles, membrane-bound structures, and cytoplasm, interior of the cell. The cell reproduction occurs by mitosis, which is the norm for genetic recombination. So these are the two comparable life forms. One's a singular life form, and the other is a multicellular life form. So as we could see, very different in their structure. And these eventually had the capability to form some kind of algae, some kind of green plant life, and then eventually bacterium, small type shrimp, bottom feeder, worms, and oceanic life. That didn't exist in this eon. It was still very singular and very simplistic. But the development of more complex life started to emerge after this time period. So that would be everything contained in the Archean Eon. A very important part of Earth's history, where water started to form, the continents started to coalesce and become more stable, land appeared, and single cellular organisms developed. And that's the part of the Eon. So if you enjoyed what you saw, please like, comment, and subscribe. And you have a good afternoon or evening.